गुड मॉर्निंग बच्चों। आज का हमारा टॉपिक है डेल्टा एच एंड डेल्टा यू, दैट इज चेंज इन एंथैल्पी एंड चेंज इन इंटरनल एनर्जी। वी विल राइट द फार्मूला फर्स्ट. डेल्टा यू is the change in internal energy is equal to NCV T2 minus T1. This formula will hold for any process, whatever be the process, let it adiabatic, let it isothermal, let it isobaric or isochoric. This formula will always hold. Okay, and here CV is nothing but the molar heat capacity at constant volume, and it is given by F by 2 into R, where F is the number of degrees of freedom. For monoatomic gas, F is equal to 3. For monoatomic like helium, neon, etc., degree of freedom is 5. For diatomic gases like hydrogen, nitrogen, etc., and F is equal to 6 for polyatomic gases like SO3, SO2, etc. So this is all about delta U, and this also can be written as heat exchange at constant volume. Okay, so delta U is nothing but heat exchange at constant volume, and it can be written as NCV T2 minus T1. Now we take change in enthalpy. So change in enthalpy will, for that H enthalpy is given by U plus P. So if I write delta H, it will be delta U plus delta of PV. Sometimes you are asked in the numerical, find delta PV if you are given the values of delta H and delta U. So you can find out by this formula, and we can always apply PV equal to nRT for an ideal gas. So I can write delta H as delta U plus delta of nRT. Okay, suppose some process is taking place at constant temperature, then I can write this as delta U plus N will be RT into delta M. Normally this is in the gaseous reactions, where there is a change in the number of moles in the reactants and in the product side. So for the reactions, that is gaseous reactions, or where one of the products is, at least one product should be gaseous, then this formula becomes delta H equal to delta U plus delta Ng into RT, where delta Ng is nothing but number of moles, total number of moles of gaseous products minus the total number of moles of gaseous reactants. So we can summarize the formula so far, that is delta U is equal to heat exchange at constant volume equal to NCV T2 minus T1, and delta H equal to heat exchange at constant pressure equal to NCP T2 minus T1, and delta H equal to delta U plus delta T. And for gaseous reactions, I can write delta H into delta U plus delta Ng RT, where delta Ng is nothing but total number of moles of gaseous products minus total number of moles of gaseous reactants. Now we take the past year questions. Which have been asked in the JEE exams. Let us first take, it was asked in 2019 main, the difference between delta H and delta U when the combustion of one mole of heptane liquid, is carried out at a temperature T, is equal to, four options are given to us, that is 4RT, then 3RT, then minus 4RT, then minus 3RT. So these are the four options and we have to find out. So we will write this equation first for combustion of heptane. Heptane is nothing but C7H16. Okay, so this will get combusted, means it will react with oxygen. This is in liquid form, oxygen in gas form. So we will get 7CO2 plus 8H2O. Oxygen is 8 plus 14, that is 22. So we will have 11 O2 to balance this equation. So what is delta Ng? Now CO2 is in gas form, H2O is liquid. So we will get total number of moles of gaseous products, that is 7, minus number of moles of gaseous reactants, that is 11. So it will be minus 4. Now our equation delta H equal to delta U plus delta Ng into RT. What we have to find out is difference between delta H and delta U. So delta H minus delta U will be equal to delta Ng RT, which will be nothing but minus 4 RT. So option C is correct. So if we can apply this equation, that is delta H equal to delta U plus delta Ng RT, to find out the required difference between delta G and delta U. Now let us take few more questions. So 4 more questions we will take, then we will wind up this session. This equation, this is given, this was asked in AIPMT exam 2012. Standard enthalpy of vaporization, that is delta vaporization H, naught for water at 100 degrees Celsius is 40.7 kilojoule per mole. It is given to us, and what is required is delta U is asked, the change in internal energy for vaporization of water at 100 degrees Celsius in kilojoule per mole is, 4 options are given to us, that is 37.6 plus 37.6, then B is your minus 43.8, C is plus 43.8, and D is minus 40.7. So these are the options given to us. So how we will do? this is enthalpy of vaporization of water. So we can write H2O liquid is in equilibrium with H2O gas. Okay. And we are given the enthalpy of vaporization at 100 degrees Celsius. That is delta H is given to us as 40.7 kilojoule per mole. It is given to us. Okay. Now we have to calculate delta U. So we will write delta H equal to delta U plus delta NGRT. So there is no reaction taking place here, but there is a change in the number of moles because H2O is in gaseous form, here it is in liquid form. So delta Ng I can write as 1 minus 0, that is 1. Now we can easily find out the value of delta U, that is delta U will be delta H minus delta NGRT. Delta Ng is already known to us. Temperature is given as 100 degrees Celsius, that is 373 Kelvin, and delta H is given to us. So we can find out the value of delta U, and the final answer will be A, that is plus 37.6 kilojoule per mole. That is how we can find out. Now let us take two more questions asked in the past year JEE exams, and this is asked in 2018 main, that is 2018. The question is the combustion of benzene, liquid gives CO2 gas and H2O liquid. Okay. Given that heat of combustion of benzene at constant volume is given to us, at constant volume is minus 3264 kilojoule per mole. Okay, this is given to us, and this is at 25 degree Celsius at STP. Okay, and the heat of combustion of benzene at constant pressure will be, so what is required is heat of combustion at constant pressure, that is to be found out, and R is given as 8.314 joule per mole Kelvin. This value we also remember, and 4 options are given to us. Okay, so we have to find out the value. So how we will do? Heat of combustion at constant volume is given to us, which is nothing but delta U equal to minus 3264 kilojoule per mole. Okay, what we have to find out is delta H, that is heat of combustion at constant pressure is nothing but delta H, and delta H equal to delta U plus delta Ng RT. Temperature is given to us, that is 298 Kelvin. Delta U is given to us, that is this much, and what we have to find out is delta H. So let us write the reaction of benzene, that is C6H6 liquid plus oxygen gas gives CO2, that is 6 CO2 plus how much H2O, that is 3 H2O. Now hydrogen is balanced. Now how much oxygen here? 8 plus 3, 11. So we can write 11 by 2 oxygen. Okay. Now this equation is balanced, and what is delta Ng here? This H2O is in liquid form, CO2 is in gaseous form. Delta Ng will be 6 minus 11 by 2. That is nothing but 6 minus 5.5. Okay. So this is nothing but 0.5. So knowing the value of delta G, Ng, we put here temperature is given to us 298 Kelvin, delta U is given, so delta H can be found out by this formula, and that will be in kilojoule per mole. So with this we wind up our session here. I hope this application of this equations is clear to you. That is nothing but delta H equal nothing but heat exchange at constant pressure equal to NCP T2 minus T1. This formula you should remember always. And then delta H equal to delta U plus delta Ng into RT, then delta H into delta U plus delta of PV. Okay, this formula you should always remember. And delta U is nothing but heat exchange at constant volume, is nothing but NCV T2 minus T1, and CV is nothing but F by 2 R, where F is the number of degrees of freedom, and Cp can be found out by Cp minus Cv equal to R. So these are the formulas which you should always keep in mind. With this, I complete the session on delta H and delta U. I hope this concept is clear. I wish all the best, and we will meet in the next session. Thank you.